Hello learners, I am Dr. MP Mishra, Faculty School of Computer and Information Sciences. I welcome you in this session related to Java programming. We will be discussing a very interesting topic in Java programming, that is polymorphism. Basically, whenever we try to learn any object-oriented programming or concept related to object orientation, one of the core concepts which comes in this particular count is the polymorphism. So about that we will be discussing in this 20 to 25 minute session. We will see certain examples, we will see some concepts, and we will try to find out that how we can experiment, how we can write code, and then how we can test the concept related to polymorphism in our exercises. So let us start. So polymorphism, when we say we see the meaning of polymorphism term in breaking this particular word in two. One is the poly, that means the many, and morphism means forms. So polymorphism means many forms, and we will be discussing about many forms of then the question mark what. So to answer to that question mark is many forms to single interface or many implementation to the single method. And that we will see that how these many implementations help in solving our problem or resolving to a better programming concept or resolving to a better presentation of the code and management of the code. So in Java, polymorphism basically enable us to perform single action in different ways. So that single action is the name of the work or name of the service or name of the method for which we are looking for, and different ways means how that particular individual service is implemented differently in different context or for the different classes. So maybe it is not much more clear to us, but gradually it will be clear that what is the meaning of the multiple implementation of the same method. Now further, if we try to look little deeper into the polymorphism concept, then we can say that it is the capability of a method to do different things based on the object which invoke or object it is acting upon. It means based on the object on which that particular method or implementation is being invoked, on the basis of that particular method or the implementation is acting or working. It means we are having different implementation of the interface which is having same name or the method which is having same name, but those different implementations are working differently on the basis of the actual object on which they are called, or the implementation which is basically done for that particular type of object or that particular kind of object, that we will try to see. Let us take one very simple example. If we are implementing, let us say, to find out the area of different shape, and we are writing a program to find area, and in that there is a method named find area. And if we are trying to implement that particular find area method to find the area of a circle shape, then obviously the implementation of that find area method will be different. And similarly, if that particular method we are trying to implement to some other type of set, let us say triangle, then for the implementation of that particular calculation of the area method for triangle will be different than the calculation of the area for circle. It means that interface is same. What we are doing for the outer side of the world, or the people who are just looking for the functionality, they are just looking that this is a method to find the area. But how actually that method is implemented for finding the area of different shape, that will be definitely based on the shape for which it is being implemented. It means the interface is same, but implementation is different. In Java, the type of actual object always determine method call. This is a kind of formula that you have to remember, or this concept you must understand. And object reference type does not play a role in it. So if we are saying the kind of object which determine that which particular method to be invoked, so here somewhat we are trying to see in terms of the hierarchy, because in hierarchy we will see there is base class and then there are some derived classes, and those derived classes object will be obviously different than the base classes, but base class can refer to those derived class objects that you already know if you have learned the inheritance concept or you have implemented the inheritance concept. So basically what we are discussing in polymorphism, that will be taking a clue from the implementation of inheritance, and from there we will be trying to find out that how actually when we are inheriting, what are the forces which are letting us go towards implementation, that we can say that this particular implementation is a polymorphic implementation, or how we are achieving polymorphism. That also we will see little later. Now, if we try to see little more closer to the core idea of the polymorphism, so we can say that it allows you to treat object of different classes in a uniform way if they share the common superclass or implement the same interface. It is another way of saying the same things, that we are having the common name, that is the find area, one example we have seen, and or if we are going through the concept of implementing the interfaces, as Java provide two type of generic to special implementation, that is one through the inheritance, and other is that you are declaring certain methods in the interfaces, and then you are implementing those interfaces as per the specific need of the different object, different classes in which those interfaces are implemented. So if there are certain methods, let us say in a class, and those methods are having certain kind of functionality, but if we can categorize those functionality and we can provide the single interface, let us say calculator example, once again we can take from the common life practices or real life example. In calculator, if I say add two numbers, then if you are adding two numbers, that is the common functionality to add. But in that addition, if we are trying to add two different type of numbers, let us say one number is integer, another number is real, then if both numbers are integer, then if both numbers are real, then it means add is the functionality which is having common name, but the working of that particular add will be entirely based on the type of argument as well as the number of argument passed to that particular method. So name of the method is same, but their prototype is different. As you know, prototype, it means the total signature of that particular method, and that signature include the return type, the name of the method or name of the function, and the number of argument passed into that function, and the type of those different arguments which are passed to the function. So this in total define the prototype, and that prototype is also called as the signature of that particular method. So on the basis of the signature of methods are differentiated, but the name of the method is same. It means there are multiple implementation of the method which is having same name, but they are having different signature. This is one way of doing the multiplicity or implementing differently with the same interface, and that particular concept is known as overriding. So we will very quickly see to the overriding. So when the concept of the polymorphism come, one question you may ask or you may have in your mind, that what are the different types of polymorphism. So to answer to this particular question is that there is static as well as there is dynamic. It means there are two types of polymorphism. So in this static polymorphism, we say that method overloading is happening. And in the static polymorphism, at the time of compilation itself decided that which method will be executed by the object on which the method is called. It means the binding of the method with the object on which that particular method is called is happened at the time of compilation itself, and this is achieved with the help of multiple implementation of the method which is having same name obviously, and the differentiation of those different implementation happen on the basis of the different type of parameter or different number of parameter, including the return types. The compiler determines which method to be called based on the argument passed during the method call for the execution. The decision of which method to be executed is made at the compiler time. So this is also known as the static binding, because at the time of compilation itself it is decided that which method will be executed by the object which is calling that particular method on the basis of the number of argument or the type of argument passed in that particular method or method call. Now very quickly let us see this particular example here on the screen. In this you can see the add method is there, but these all three different add methods. One add method is here. In this add method there are two integer values passed and return type is integer. Second one is that a double is being returned and two double variables are passed. And third one is that in integer value is being returned, but there are three arguments which are of integer type are being passed. It means we are having three implementation for the same name, that is add. So here we can say that the interface or the functionality or the service name is add, but implementation of that service is done in three different ways based on the three different requirement or three different functionality of that particular individual method. So these three different implementation, basically what they are doing is that these are doing method overloading. So more than one implementation of the same method name is there, but the signature of all those different implementations are different, so that they can be identified at the time of compilation that which method is called. So here in actual implementation inside the main method, if you see, obviously the object is created calc, and on calc if add 2 and 3 is being passed, it means two integer values are passed, so method 1 is being invoked. If two real double values are passed, then it is calling another method. Similarly, if three arguments are passed, it is calling some other method. It means the calling of the method is being decided on the basis of the signature of the method which is being called by the object. So that signature is very important when the concept of overloading we are trying to implement. You can practice other exercises also. For example, calculate salary. In that, if some employees are there who are having some different kind of variable attributes associated with their salary calculation, so calculate salary method will be same. Return type obviously may be the real or integer, but the argument which you are passing in different calculate salary methods, that may vary as per the specific type of or category of the employees, and you can practice this exercise. And similarly, few more example you may explore and try to implement that. And some more on method overloading if we try to see, so we can say that similar kind of methods are there in a class and they have the same name and same, but signature is different, and by the mechanism of type or the order of the argument passed to that particular method is decided that which method to be executed. Sometime overloaded method may not have, may have their different return types, but that individually is not going to decide. It's all depend on in total what is the signature of that particular method. So that on the basis of that it will be decided that which method is to be invoked or to be executed. Here you can say one method area with one integer. So this particular is calculating area. Similarly, another method area that is having 2 argument, and similarly here you can say that these 2 methods are being invoked on the basis of the number of argument passed in these 2 methods. It is being decided that which method to be called. So in overloading, remember that method calling or method binding with the object will be decided on the basis of the signature of the method. So when you are doing overriding or trying to define the methods in such a way that the methods are overridden, you must have to ensure that the signature of the different methods which are overloaded inside a class, they are having different signature. And method overloading happen within a class only. It means inside a class, if there are different implementation of the method which is having same name but different signature, then we say that it is overloading and it is happening inside a single class. Now next comes the runtime polymorphism, or that is dynamic binding or dynamic polymorphism or method overriding. In method overriding, whenever we are doing inheritance or object oriented programming, our one key purpose is the code reusability. For that purpose only we are doing the inheritance. So when inheritance we are doing, and in that particular inheritance if we are trying to take something from the parent class to the child class, or we are inheriting the property in the child class, so situation may arise that whatever implementation of certain method in the parent class is there, that is the very generic implementation in the parent class, and child class is trying to supersede that particular implementation, or they are trying to hide the implementation of the parent class and they are having their own implementation for that particular method in the derived class. So in that way overriding is happening. It means whatever method is there with the exact name, signature, return type, everything is same in the parent class, and that we are trying to, the implementation of the parent class we are trying to hide in the child class, and we are implementing the own implementation inside that particular child class to perform the specific activity, but the interface name is same. So in that case overriding happen, and overriding basically happens in the case of when we are having inheritance hierarchy, parent childs, or there is a parent class and then derived classes are there, or there is a hierarchy of derived classes, and in the derived classes the method with the same signature is being implemented differently, then we say that we are doing the overriding of the method. So in the case of this runtime polymorphism, we require inheritance, the existence of superclass and subclass. Now very quickly let me see one example here. So let us say there is an animal class, and this particular animal makes certain kind of sound. So this is the parent class or the superclass, and then in superclass there is a method make sound. This method is doing something. So a class dog is derived from the animal class. It means we are having a specific subclass that is derived from the superclass, and we are overriding the make sound method, and we are having now the specific implementation as per the requirement of the dog in that particular make sound method. So similarly another class is there, that is cat, and this cat class is again overriding the make sound method, and the implementation of make sound method is as per the specific requirement of that particular derived class, and in this case is that class cat. So now if we are defining objects or creating objects, so here you can say, you can see here animal 1 object is of type animal, it means of type parent class. Animal 2 is of type dog, that is the derived class of the parent class animal. Similarly, animal 3 object is of type cat, that is another type of object. Now you see animal 1 makes sound. If this method is being invoked, so this particular method will be invoked on the type of the object, which is animal 1 is. It means from the class this particular object is derived, from that class the implementation of make sound method will be executed. Similarly, for animal 2, it will be another one that belong to wolf, and similarly for the belong to the dog, and the third one belong to cat, and that particular will be executed. So on the basis of the type of object which is referring to the method, that particular method is being invoked, and in this way we are having specific implementation on the basis of different classes requirements. Obviously there will be very large number of objects in real life scenario of that specific type, and those all objects are having their own specific requirement for the implementation, and on the basis of that implementation, the interface which is having the same name in the parent class, it is having its own implementation in the parent class. The same method in the derived class is having different implementation as per the requirement of the derived class. If in this way we are doing the implementation, it is called overriding, and overriding provide a lot of flexibility in terms of extending the design of the system, or it provide sometime the concept of the abstraction you do in the parent class, and then you implement those abstraction in the derived class as per the specific requirement. We are not discussing here the abstract class concept, but that is also somewhat correlated with this polymorphism concept, and it provide heavy implementation of the polymorphism in the case of abstract class. Some more on method overriding, if we try to see little more closer to it, so we can say that subclasses extend the parent class, and it has access of non-private methods of the parent. To hide the parent class implementation in derived class, we are having their own implementation, and that is why the methods are overridden. And some important point that we have to take care is that an overriding method replaces the method which is present in the parent class. Each method in parent class can be overridden at most once in a derived class. Overriding method must have exactly same signature. Overriding must have exactly same return type. So here another example, just I am showing this example, you can experiment on this particular. Here is a figure class. This figure class is having its own implementation. It is having its own, you can say, the constructor overloading, then it is having some method, and then again you are deriving some different type of figures, and then you are trying to override the implementation of the parent method, that is the area, and this particular overriding is happening exactly in another implementation also, that is the square. So different kind of shape you are having. In those different kind of shape you are trying to calculate the area, and on the basis of that you are doing. So in this way you can experiment on it, and you can see how actually the polymorphism is working. And in next session I will be discussing little more on polymorphism, that is that how you must have to ensure that by accident you are not overriding the methods. That is very important to note, otherwise it will be very difficult for you as a designer or implementer to manage the system. And if you are having properly defined things, and in parent class if something is defined, in derived class if something is defined, so unnecessarily don't try to modify parent class too much. Otherwise, it reflects on the hierarchy, and in derived classes also get disturbed. So in that way, the whole idea of implementation of the things differently for the derived class also may get diluted, and it may not work properly. So those all things we have to take care. And if our implementation hierarchy is too deep, then also there will be problem, and the complexity of the whole code management and implementation will be difficult, and overall it will be very difficult to manage such a complex situation. So in next session we will be discussing more on the polymorphism, and we will see that how we can make a good system using object oriented concept, that is polymorphism, and do better programming. Thank you very much.